In a quiet moment of a sun-drenched afternoon, a simple act can unfold into a profound question. A hand reaches out to a flower, and in an instant, a sharp, piercing pain. The source of the pain, a tiny honey bee, flies away. But only for a moment. Its frantic, disoriented flight is short-lived. It falls to the ground, its small body shuddering in a silent, violent struggle. And then, a final stillness. Its life, a journey of a few brief weeks, has come to a sudden, absolute end. It leaves behind not just the memory of a sting, but a haunting, indelible image of sacrifice. The bee, a creature that is the very symbol of industry and community, has given its life for a single, final act of defense. This is not a simple biological fact to be filed away and forgotten. It is a story of purpose, of an ending that is intertwined with a beginning. It is a question that forces us to look beyond our own pain and into the very heart of nature's most tragic and beautiful paradoxes. Today, we will delve into the science and the philosophy behind this final sting. We will uncover the secrets of a weapon designed for a single, fatal use. We will explore the evolutionary logic that dictates an individual's demise for the sake of the collective. And in doing so, we might just find a deeper understanding of our own place in the intricate, interconnected web of life. To truly grasp the reason behind this ultimate sacrifice, we must first understand the weapon itself. The honeybee stinger is a masterpiece of natural engineering, a tool of both life and death. It is not just a simple needle, as a cursory glance might suggest. Under a microscope, it reveals its true, lethal design. Its structure is not smooth and sleek like that of a wasp or a hornet. Instead, it is serrated, lined with a series of backward-facing barbs, much like a tiny, biological harpoon. These barbs are the key to the bee's tragic fate. They are its strength, and they are its undoing. The stinger, in biological terms, is a modified ovipositor, the egg-laying apparatus of a female insect. In worker bees, who are all female, this organ has been repurposed entirely for defense. It is connected not just to a venom sac, which pumps a potent cocktail of neurotoxins and enzymes into the victim, but also to a network of muscles, nerves, and most critically, to the bee's digestive system. The stinger is an extension of the bee's very core, a deeply integrated part of its internal machinery. When a honeybee stings, it does so with immense force and conviction. It is not a casual act. The barbs are designed to lodge securely in the skin of its target. While it might be able to sting another insect with a hard exoskeleton and then withdraw, this is not the case when it encounters a mammal. Against the thick, elastic skin of a human or a bear, the barbs become hopelessly embedded. The stinger becomes a prisoner in the very skin it was meant to defend against. This is the moment the tragedy unfolds. The bee, having delivered its venom, tries to pull away. Its powerful flight muscles, built for the tireless labor of foraging, now work against it. It strains, it pulls, it struggles, but the barbs hold fast. The immense force generated by its struggle to escape is too much for its delicate body to bear. The stinger, along with the venom sac, a portion of its digestive tract, its nerve ganglia, and other vital organs, is ripped from its abdomen. This is not a slow, peaceful death. It is a violent, catastrophic evisceration. The bee's body is torn open, and its internal organs are scattered. The trauma is so great that its life ends within minutes, sometimes even seconds. The small, buzzing life, so full of purpose just moments before, is extinguished in a single, fatal tear. And yet, the stinger continues its work. The venom sac, now a separate entity, continues to pump its deadly fluid into the wound. This is a cruel, yet brilliant, evolutionary design. The stinger, now a self-contained biological weapon, ensures that the maximum amount of venom is delivered, maximizing the pain and the defensive impact. Furthermore, the venom contains a specific pheromone, an alarm pheromone. that acts as a chemical signal to the other bees in the colony. It draws them to the site of the danger, signaling a threat and turning the singular, tragic death into a call to arms for the rest of the hive. The death of one bee becomes the defense of thousands. But a deeper question remains. Why did evolution, a process driven by the survival of the individual, create such a lethal, suicidal trait? The answer lies in understanding the honeybee not as an individual, but as a part of a superorganism, the bee colony. A honeybee worker's life is not its own. Its sole purpose, its very existence, is to serve the hive. In a thriving colony, there are tens of thousands of worker bees. The death of one is a small price to pay for the survival of the queen and the thousands of future bees she will produce. The honeybee's stinger, with its fatal design, is a weapon of mass defense, not self-defense. The honeybee evolved to defend its colony from large, furry predators such as bears, raccoons, and even early humans. These predators pose a grave threat to the hive's stored honey, its brood, and most importantly, the queen. A single sting might be a minor inconvenience to a bear, but a swarm of bees, each willing to make the ultimate sacrifice, is a deterrent that even the largest predator would find unbearable. The barbed stinger ensures that the sting remains in the victim, continuing to cause pain and maximizing the defensive impact, even as the bee itself falls to its death. And yet, the story is not a universal one. This tragic fate is not shared by all stinging insects. The bumblebee, for instance, a close cousin of the honeybee, possesses a stinger that is smooth and lacks barbs. This allows the bumblebee to sting an intruder and then easily withdraw its stinger, surviving to sting again another day. The same is true of wasps and hornets. Why the difference? The answer, once again, lies in the evolutionary pressures each species faces. Bumblebee colonies are much smaller and less populous than honeybee hives. They are seasonal, and the loss of a single worker bee is a significant blow to the colony's ability to forage and reproduce. The individual's life is therefore more valuable, and its survival is a priority. The bumblebee's strategy is to survive and continue to defend, whereas the honeybee's is to die, but to ensure the defense is absolute. It is a testament to the different paths that evolution can take, a beautiful and somber reminder that in nature, there is no single right answer to the question of survival. In our modern world, this tragic sacrifice has taken on an even deeper, more heartbreaking dimension. For decades, we have been witnessing a silent crisis unfold, colony collapse disorder. Bee populations around the globe are in a steep and alarming decline. The reasons are complex and multifaceted, ranging from the widespread use of pesticides to habitat loss to the effects of climate change. The very ecosystem that the bee has so tirelessly served is now under threat, and with it, the existence of the bee itself. The death of a honeybee, once a small and insignificant part of a thriving colony, has now become a much more poignant event. Every bee that makes the ultimate sacrifice today is one less bee in a dwindling population. The tragedy of the individual bee's death is now compounded by the potential tragedy of the collective. This superorganism that the bee was willing to die for is now on the brink of a crisis, and its future hangs in the balance. And in this story, we, as humans, are inextricably linked. We are the beneficiaries of the bee's labor, and we are, in many ways, the source of its peril. We rely on bees to pollinate more than a third of the crops we consume daily. Our almonds, our apples, our countless fruits, vegetables, and nuts all exist because of the bee's work. Its life is a constant act of service, and its death is the ultimate act of protection. We return to the beginning, to the quiet garden and the small, fallen bee. Its death is not a simple biological fact. It is a narrative of life and death, of purpose and sacrifice. The bee teaches us that the individual may perish so that the community may live. It reminds us that existence is not just about the survival of the self, but about being a part of a larger, interconnected web. In this final act, the bee leaves us with more than just a sting. It leaves us with a question, a reflection on life, death, and the delicate balance of the world we share. Perhaps, in understanding its sacrifice, we can learn to appreciate its life and to protect the vital role it plays in our own survival.